What's happening, you wacky YouTube folk? I'm Mr. What, but only for the duration of this video. As soon as it's over, I'm going to be returning to my day job of being a discreet yet tasteful beauty mark somewhere on Christina Hendricks' lovely frame. Putting my personal pipe dreams aside, we're coming up on the anniversary of the posting of the amix video that I made. And admittedly, there were some details that that particular video was lacking, particularly on the availability of amix in different versions of FFmpeg or its forked equivalent avconv, or avconv, however you want to pronounce that. So I hope to add some of those details into this video, but it's not the main subject that I'm going to be covering this time around. This time I'm going to be covering a filter graph called asyncts. And this stems from a comment that was posted, well, it was over 3 months ago by a user named Pavawit. And he said, I want to record video of a full screen game like Counter-Strike Go with audio only from speaker. My command is like below, but I got a problem. The sound is delayed by about 2 seconds and how to fix it. Now, the answer that I originally supplied him wasn't really relevant to keeping your audio synchronized explicitly. It can be helpful. It really just covered making sure that your CPU frequency scaling was set so that when you're running a recording, you're using the most available CPU horsepower that your machine can supply. While that is handy for screen recordings, it's not guaranteed to keep your audio synchronized. And all things being what they are, at the time, the majority of the desktop recordings that I was doing was tutorials for my coworkers. I didn't really need to use multiple audio sources, just a microphone for doing those. And I discovered that my own audio synchronization problems started cropping up if I decided to play back an audio clip or a video clip in the middle of one of those recordings. My microphone never seems to fall out of sync. But using my desktop audio in any capacity, if I wait like 10, 20, 30 minutes down the line before launching some video player that pumps audio through that second input, that's when it falls out of synchronization. Anyway, before we get too far into the weeds of dealing with the asyncts filter, there's a few important points that I want to make certain are covered. The first and most important is that I am not an expert in FFmpeg by any stretch of the imagination. Seriously. I know just enough of this stuff to be a danger to myself, so don't let me be a danger to you. Make certain that you do your own research, and more importantly, run your own tests. I like to call it better living through reckless experimentation, and I think it's something that many people using FFmpeg should adopt, especially considering the state of their documentation. Okay, now concerning these filters, both asyncts and amix were introduced into FFmpeg in version 0.11 in late May of 2012. Depending on your distro, if you have a version of FFmpeg that is 0.11 or higher, you should, or at least might, have these filters available. Your build configuration needs to include a setting called enable libsw resample for these to both be included at the same time. You can test to see if these filters are available by using ffmpeg --filters pipe grep amix or grep asyncts to see if they're included in your build. Okay? Just a quick test there. Now comes Ubuntu. Oh, Ubuntu, you poor fool. It's important to note that the default repositories for Ubuntu releases, derivatives, and respins don't have FFmpeg, or at least a genuine version of it, available. They use avconv, which is a libav.org's fork of FFmpeg. Okay? Now, I can't really speak to the functionality of avconv. I know that it is feature compatible, and in most cases command compatible. Just by trading the word FFmpeg to launch the thing out with avconv, you should be able to use the same script syntax in either program. However, from what I've been able to gather in doing some online research, when avconv was forked, libav.org went ahead and they took FFmpeg and started writing their own version. They literally started writing their own version. They were doing a practice called not coded here. So whenever a new feature was released in FFmpeg, instead of taking that and using it as upstream source and implementing it into avconv, the libav.org's team ended up rewriting the code from scratch. So, like I said, I'm more familiar with FFmpeg than I am with avconv. your mileage is definitely going to vary on this. Now, versions of Ubuntu that are less than or equal to 13.10, that includes the 12.04 long-term support release, have a version of avconv that is feature equivalent to FFmpeg 0.10. And that means that the asyncts, TS, and amix filter graphs are not available in that build. And that is very important to note. If you have installed a genuine version of FFmpeg through John Severinsen's PPA for Ubuntu, it will not provide a more recent version of FFmpeg than the 0.10 branch than for any respin that is less than or equal to 13.10. Okay? Versions 14.04, 14.10, they have an avconv equivalent to FFmpeg version 1.2. So async, TS, and amix are available and they do work. So if you have 14.04, at this point I would hope that you would, or 14.10 if you decide to go with a short-term route, using avconv with the scripts that I'm going to start running through in this particular demonstration, they'll do the trick. Okay? Now, if you're still on 12.04 and you decided to try out one of ffmpeg.org's static builds, they have these pre-compiled versions available for download on their website. They don't have the X11 grab enabled, so they can't be used for recording your desktop. If you're on 12.04, really the only option that you have for using amix and async TS is to roll your own version of Ubuntu. And on FFmpeg's wiki, there is a compilation guide for downloading all the relevant libraries and building your own version of FFmpeg. So there are a few things missing from the instructions. I think that they missed the video for Linux 2 in there. I don't think that they included the enable libsw resample and a couple other things. That may be worth its own video down the line. We'll see how it goes. Whatever the future holds. Anyway, so back to async TS. Using this for a single input can be as simple as -filter underscore complex space async and CTS, like that. Okay. If you're using multiple inputs with amix, things are going to get a little bit more complicated. But let's burn that bridge after we've crossed it. So I'm going to go back to the FFmpeg documentation, and I want to cover a few things about the options that are available for this particular filter. These parameters are here. Compensate, which enables stretching or squeezing the audio data to make it match the timestamps. The way that the filter works is that whenever you start a recording, it starts generating what's called presentation timestamps, or PTS. For each individual audio input, presentation timestamps are based on the sample rate that you're using. In this case, I'm going to flip over to the command that I'm using to record this particular video right now. Sample rate would just be 44.1 kilohertz, 48 kilohertz, or 44,100. So that's 44,100 samples per second. Presentation timestamp would say that in when you reach the 1 second mark, you have grabbed 44,100 samples of audio. Now, when FFmpeg starts recording from live inputs, like we're using microphones and desktop monitors through Pulse, in that particular case, it's recording from audio buffers. So what the async TS filter does is it compares the presentation timestamps against the time data coming from the audio stream. If they don't match, what it ends up doing is it dumps the audio buffer and starts over. You'll notice that in my particular recording here, there are these messages that say non-monotonous timestamps dropping whole buffer. These are points when it found that the audio input from one of the 3 sources that I've defined were no longer in sync, and it dumped the buffer to get it back into sync. Okay. You said parse async TS2, so that would most likely be the 3rd input in my line here, just because everything in FFmpeg is numbered starting in 0. Anyway, so for a single line like Pavawit was using, let's just go ahead and let's just take this and let's tweak it a little bit so it would be useful. Copy. I know this is way far after the fact, but okay, I'm going to paste that in here. So all I need to do is drop async TS with the appropriate backslash after the inputs have been defined. You could slap this in right after the pulse input, or you could slap, you know, like I've done here, after the X11 grab input. I've kind of learned to string these things together in a little bit more coherent manner. So, for example, I'm going to move the pixel format designation for YUV 420p up to the libx264 input. This should keep his stereo monitor in sync as he's running the recording. Okay. Now, if he was using multiple inputs, I'm going to go ahead and crack and open a fresh terminal here. So let's pick a couple of inputs here. PACTL, less sources, short. So we don't have to look through massive menus of stuff. Let's say, for example, and I have a couple of things plugged in here, that I wanted to use the microphone from my camera, which would be this line here, also input USB Pro webcam C920. I don't use the microphone on the camera because it sounds horrible. Let's copy that one. And let's go ahead and drop it in down here. And let's say that we're using USB headset, which I have plugged into the system for the sake of further demonstration. Let's copy that thing. And let's plug that in. And that is the monitor for that headset, not the microphone attached to it. The microphone is actually right here. Let's copy that. And let's put it like that so that we have two microphones and then one stereo monitor. Okay, so force input, force pulse, and let's just make these things even. What the hell did I do? I did channels and sample rate. Dash AC2 dash AR 44100. And let's just say that these inputs are using the same channels and sample rates all the way through. And like so. If I can remember where my cursor is, it'd probably be helpful. There we go. That's all tidy. So, what I'm going to do here is, let's say, for example, that I have these complex amix equals puts equals 3. Let's say, for example, that I wanted to use these 3 inputs, but I wanted to make certain that they were kept in sync. Then what I'd have to do is set up what's called a filter chain. Now, asyncts itself can only accept one audio input at a time. If I have 3 audio inputs that run the risk of falling out of synchronization, that means that I need to designate 3 separate instances of asyncts in the filter complex line here, or in the filter complex chunk, command, whatever you want to call it, to make certain that everything stays squared up. Now, whenever you're doing a filter chain, you do have to make certain that all of the components of the filter are surrounded in double quotes. So you'll notice I put the space backslash after filter complex. Next line I'm starting with a double quote, and then when I get to the end of the filter chain, it will be closed with a double quote. Now, each of the individual inputs for a desktop recording are numbered automatically by FFmpeg as soon as the recording starts. The outputs are also numbered. The numbers start at 0. Now, you'll notice that the first thing that I have listed here is the microphone from the webcam. So what I need to do is I need to specify which input is going to go into the first async TS string. That's going to be 0 TS. And the next thing that I need to do is I need to set up what's called a link alias. So I'm going to call that cam mic. Now, these link aliases, they should be fairly simple. I could just, drill it down to like C if I wanted to, just to make certain that I knew what I'm doing with it. It'd be best if you, definitely don't put any spaces in there. You can put, if you really want to, some punctuation, but I would keep it just as simple as possible. Okay. And now I'm going to put a comma, space, backslash, next line. No quotes. Remember, I'm not closing the quotes out yet. So to designate the input for the headset microphone, analog-stereo at the end there, that is input number 1. Async syncts, and then I can call this HM, or headset microphone. Okay. And the third input, which would be 2 in this case, FFmpeg input number 2. We have 0, 1, and 2, and this is the last one. Async, damn it, probably help if I spelled that correctly. Syncts. And then I'm going to call that, and let's just call it S. Pretend that it stands for speakers, which in this case it probably would be. Okay. Now, when you are setting up these filter chains, what we're done here is these numbers designate the input. So 0 represents the webcam microphone. I'm piping it into asyncts, and the end result, the filtered output, is now going to be referred to by the link alias C. Okay? And the second input here, which is the microphone of a Logitech headset, once it's passed through asyncts, its output is going to be represented by HM. Third input, it's going to be represented by S. So in order to pass these altered inputs into amix, now what I have to do is use the link aliases. There's 3 of them, so I'm going to put square brackets around them. C for the webcam microphone, HM for the headset microphone, and then S for the headset speakers. We have now completed the filter chain that will successfully keep each individual audio input in sync and then pass the synchronized inputs into amix. Now, a lot of people may be looking at this and say, well, why can't you just do async TS after amix? Well, the reason for that is because, once all the audio inputs are passed into amix, they're out of sync if you don't designate that first. So, anyway, this is the only way that you're going to be able to set this up successfully. Okay. Now, concerning the options with the asyncts, you'll notice that I didn't use any in this command string, and that is because it doesn't really need any options to be input. The option that it does have, compensate, enable stretching and squeezing the data to make it match the timestamps. So it'll either speed up or slow down audio input in attempting to make it match. It is disabled by default, and all things being what they are, it should stay that way. Now, I have an example of what it sounds like when you try to use that. Let's give it a couple of seconds to start up here. Yeah, no, that doesn't work. So there's no reason to include it because it's disabled by default. Minimum delta. This is the minimum difference between the timestamps and the audio data in seconds to trigger adding or dropping samples. The default value is 0.1. Personally, since I've discovered and started using asyncts, I've had no reason to change that. However, it does note that if you get an imperfect sync with this filter, you could try setting this parameter to 0. So, if you wanted to include minimum delta, it would just be asyncts equals min_DLTA equals 0 instead of 0.1. Like I said, I have not found it to be necessary since I have started using this. It has done a really good job keeping everything squared up. So we're going to ignore that. Max comp, maximum compensation in samples per second. This is only relevant with compensate equals 1. So because compensate is going to remain turned off, you don't need to use it. First PTS, affirm that the first PTS would be this value. You do not need to set that either. When you're starting a recording with live inputs from scratch, the first timestamp or the first presentation timestamp is always going to be 1 divided by whatever the sample rate of the input is. So there's really no need to set that either. Now, amix itself has options similar to async TS. However, when you're using it for live inputs, like we're using your desktop monitor or your inputs, you don't have to set those either. So really the only option that you need to use is inputs, and then count the number of inputs. If you had 2 inputs, that is amix's default. So if I were to carve one of these out, like so, that's all I would need. Okay. Let's put this thing back in here, but it's not going to hurt anything to keep it. Some of the other options for amix are more relevant if you're attempting to do a mix down of pre-encoded files, things like dropout transition for normalization, or when what to regard as the benchmark audio input, to determine when the recording stops. When you're using live inputs, none of that matters, because they start when you start the recording and they stop when you stop the recording. That's pretty much the way that works. Anyway, so just for the sake of hammering examples through, I don't need that. I have here an example of some audio desynchronization. I'm hitting the wrong pause button. And if you remember that, let me get this thing out of minimize for a second. Go back to gedit. In this recording string that I'm using now, I have my analog stereo.monitor. That's my desktop audio, and I also have the monitor for this USB headset that I mentioned previously. Now, until I got this particular blue microphone that I'm using now, and I happen to like quite a bit, I was using this Logitech headset because I like the microphone quality. However, when I was using it as a headset and a microphone at the same time, the microphone input sounded horrible. So on the rare cases when I was using it, if I flip over to the volume control here, let's move that back up to 100%. I didn't specifically need to hear anything coming through my normal speaker channels when I was doing the recording. So if I was playing back a clip or something like that, but on the cases that I needed to actually listen to it as it was progressing, I could just go into my playback tab for whatever program was pumping out audio on my desktop. I could flip over to the USB headset as the output, and because I had specified both my desktop audio as a monitor and the headset as a monitor, the recording picked up the audio from both sources without dropping anything. However, when I did not have these synchronized, before I was using async, this is a test of how far out of sync the audio can fall when I was switching back and forth between the audio outputs, both my desktop audio and that headset. So let's go ahead, I'm going to full screen this thing again, and let's just resume it. Okay, I'm using, if you'll notice, the audio is already a bit out of sync on this. That's because this is pretty far along in the particular recording. You'll also notice that, why am I using a cartoon for this? Cartoons made by Fleischer Studios are considered by animation students to be high benchmarks for audio sync, or syncing or lip syncing animation to complex audio tracks. This isn't the first example that I would pick of that, but at the same time, it's in the public domain, so nobody's going to scream at me for using this particular cartoon as an example.
Let her go, oh bless her, wherever she may be. She will search this wide world over, but she'll never find another sweet man like me. Now when I die, bear me in my straight leg breeches, put on a box back coat and a Stetson hat, put a $20 gold piece on my watch chain, so you can let all the boys know I died standing pat.
Okay, let's try the headset. You see how far off, how far out of sync that was when I switched over to using the headset in this particular example? It was like a 2-second lag before the audio came through. And I will tell you that, you know, the audio when I was listening to it was perfectly fine. So let's just keep going with it.
Let her go, oh bless her. Wherever she may be, she will search this wide world over, but she'll never find another sweet man like me. Now when I die, bear me in my straight leg breeches, put on a box back coat and a Stetson hat. Put a $20 gold piece on my watch chain so you can let all the boys know I died standing fast.
Let's flip back over to built-in. Yeah, right about there.
Down to St. James Infirmary. See my baby there, she's stressed out on a long white table. She's so sweet, so cold, so fair. Let her go, oh bless her. Wherever she may be, she will search this wide world over, but she'll never find another sweet man like me.
Okay, you can see how horrible that ended up being. Anyway, what I'm going to do now is, because I do have async TS active for all of my audio inputs, I'm going to go ahead and play back a couple of examples, or a couple of I'm just going to play back this video here, take it out of full screen mode. I do need to reset this thing back. There we go. I'll just minimize this. There we go. Now the audio on this particular MPEG is really quiet, so I had to go ahead into the equalizer and enable a preamp boost on it. But let's scrub ahead to about, where was it? This will do. Where is it? 240. This ought to do the trick. Okay, I'm just going to start from right about the beginning of the song, and then I'm going to go ahead and scrub back and forth in this while it's playing, and I'll switch some of the outputs. If you watch the input down here, you'll see when FFmpeg runs across a bad sync point, you'll see these non-monotonous timestamps dropping whole buffer messages start popping up. So that's why I've got that set up the way it is. Make sure I can get to the volume control too. And let's go for it.
Folks, I'm going down to St. James Infirmary. See my baby there, she's stressed out on a long white table. She's so sweet, so cold, so fair. Let her go, oh bless her. Wherever she may be, she will search this wide world over, but she'll never find another sweet man like me. Now when I die, bear me in my straight leg breeches, put on a box back coat and a Stetson hat. Put a $20 gold piece on my watch chain so you can let all the boys know I died standing fast.
Okay, let's just back this thing up straight up there.
Let her go, oh bless her. Wherever she may be, she will search this wide world over, but she'll never find another sweet man like me. Now when I die, bear me in my straight leg breeches, put on a box back coat and a Stetson hat. Put a $20 gold piece on my watch chain so you can let all the boys know I died standing proud. Then give me 6 crap shooting pallbearers. Leave my baby there, she's stressed out on a long white table. She's so sweet, so cold, so fair. She will search this wide world over, but you never find another sweet man like me. Now when I die, bear me in my straight leg breeches, put on a box back coat and a Stetson hat. Put a $20 gold piece on my watch chain so you can let all the boys know I died standing pat.
Okay, I think at this point you kind of get the idea. If I didn't have async TS involved in my particular recording script here, then you would have seen the audio fall way out of sync with each instance of me scrubbing the timeline on that video back and forth and then switching the inputs and outputs around. So the good news is that, through this particular example, I was able to prove that it works. So now I'm leaving it all up to you to go try this for yourselves. And remember, better living through reckless experimentation. That's the name of the game, people. So until the next time, I'm hitting Q.